Good morning, everybody. I am Anusha of CSC department, working as assistant professor in Institute of Aeronautical Engineering. In today's video, I will be discussing about event handling, delegation event model, event source and event listeners. In a previous video, we have discussed about graphical user interface programming in Java, the AWT classes, and we just gave an introduction to the swing. I have also discussed about the various layout management interface layout management in that video. So let's move on to today's video. So in Java, all the almost all graphical user interface programs will create some events. Like for example, if you press a key in the keyboard, that generates an event. If you move the mouse, it will generate another event. When the mouse moves into a container or into from outside the component, it will generate any event. So there are various events which can be generated by any action inside Java. So for handling all those events, we have these event handling mechanisms. So this is the fundamental Java programming technique, which is integral part to create many kinds of applications. These are also used in developing applets and other GUI based programs. Any program that uses graphical user interface is event driven. There are a number of packages which is supported, like java.util, java.awt event and java.awt. The various type of events, including those generated by the mouse, keyboard, various GUI controls such as pushing a button, scroll bar, etc., are generates any event. The swing follows the delegation event model. So this is a modern approach for handling the events. The delegation event model has two parts: a source and the listener. The source part will generate any event, and that is sent to any listener. So whenever an event occurs, the source invokes the appropriate method defined by the listener and provides an event object as its argument. So the listener simply waits until it receives an event. Once an event is received, the listener processes the event and then it returns. The advantage of this design is that the application logic that processes event is cleanly separated from the user interface that generate those events. A user interface element is able to delegate the processing of an event to a separate piece of code. The listener part will always should register with a source in order to receive an event notification. This have the benefit that the notification are only sent to the listeners which are meant to receive them. In olden days, the event was propagated up the containment hierarchy until it was handled by a component. This required components to receive events that they did not process and wasted valuable time. The delegation event model eliminates this overhead. The delegation event model is based on the following three components: events, event sources, and event listeners. Let's look into events. An event is an object that describes a state change in a source. An event can be generated as a consequence of a person interacting with the elements in the graphical user interface. Examples that causes an event are pressing a button, entering a character through keyboard, detecting an item, selecting an item in a list, clicking the mouse, the expiry of a timer, a counter exceeding a value, the software or hardware failure, or any operation completion. So these are the various events that can be generated by any event objects. We have different events. For example, we have window events, which is generated when a window is destroyed, exposed, iconified or de-iconified, or moving the windows. Mouse events can be generated by moving the mouse, dragging the mouse, having the mouse enter or exit a component, pressing a mouse button and releasing of a mouse button. The keyboard events can be created by pressing the key, releasing the key, etc. List event is caused by selecting or deselecting a list item. Scrolling events can be generated by the scrolling a line up or down, or scrolling a page up or down, or scrolling to an exact location. These are the commonly used event classes in java.awt.event. The action event is generated when a button is pressed, a list item is double-clicked, or a menu item is selected. Adjustment event is generated when a scroll bar is manipulated. Component event is generated when a component is hidden, moved, resized, or becomes visible. Container event generated when a component is added to or moved from a container. Focus event is generated when the component gains or loses the keyword focus. Input event is the abstract class for all component input event classes. Item event is generated when a checkbox or a list of item is clicked. Also occurs when a choice selection is made or checkable menu item is selected or deselected. Key event is generated when the input is received from the keyboard. Mouse event is generated when mouse is dragged, moved, clicked, pressed, or released, or also generated when the mouse enters or exits a component. Mouse wheel event is generated when the value of when the mouse wheel is moved. Text event is generated when the value of a text area or text field is changed. And window event is generated when the window is activated, closed, deactivated, de-iconified, iconified, opened, or quit. Next, the event sources. So, a source is an object that generates an event. This occurs when the internal state of that object changes in some way. A source must register listeners in the order for the listeners to receive notification about a specific type of event. When an event occurs, the event source invokes the appropriate method defined by the listener and provides an event object as its argument. Each type of event has its own registration method. The general form is public void add type listener, and the parameters passed to it will be of type listener. So here this add method can be customized according to the various type. It can be a mouse listener or it can be a key listener. So there are, based on the type, there are various other listener methods. So whenever a source generates an event, an information, a message will be passed to the listeners so that the listener can take appropriate action based on what is defined it. Now, these are the various sources that can generate any events. The button, it generates action events when a button is pressed. Checkbox generates item events when checkbox is selected or deselected. Choice generates select item events when the choice is changed. List generates action events when an item is double-clicked. Generates an item event when an item is selected or deselected. Menu item generates an action event when a menu item is selected, generated. Generates items when item events when a checkable menu item is selected or deselected. Scrollbar generates adjustment events when the scrollbar is manipulated. Text components generates text event when the user enters a character, and window generates window events when a window is activated, closed, deactivated, de-iconified, iconified, opened, or quit. Next is the event listener. So the listener is an object that is notified when an event occurs. It has two major requirements. One is that it must be registered with one or more sources to receive the notification about the specific type of events, and it must implement the methods to receive and process these notifications. The methods that receive and process events are defined in a set of interfaces found inside java.awt.event. These are the commonly used event listener interfaces. The action listener defines one method to receive action events. Adjustment listener defines one method to receive adjustment event. Component listener defines 4 methods to recognize when a component is hidden, moved, resized, or shown. Container listener defines 2 methods to recognize when a component is added to or removed from a container. A container listener defines 2 methods to recognize when a component is added to or removed from a container. The focus listener defines 2 methods to recognize when a component gains or loses keyboard focus. Item listener defines 1 method to recognize when the state of an item changes. The item key listener defines 3 methods to recognize when a key is pressed, released, or typed. Mouse listener defines 5 methods to recognize when the mouse is clicked, enters a component, exits a component, when it is pressed or it is released. The mouse motion listener defines 2 methods to recognize when the mouse is dragged or moved. The mouse wheel listener defines 1 method to recognize when the mouse wheel is moved. The text listener defines 1 method to recognize when a text value changes. The window focus listener defines 2 methods to recognize when a window gains or loses input focus. And the window listener defines 7 methods to recognize when a window is activated, closed, deactivated, de-iconified, iconified, opened, or quit. Now, these are the various registration method available within the component of for the listener. So, for registering the component with the listener, these classes can be used. For example, the button uses the button class, menu item class uses the add action listener method. The text field uses the add action listener and the add text listener method. The text area and list uses the add action listener method. The checkbox uses the add item listener method, and the list also make use of the add item listener method. Now let's look into an example for implementing the mouse listener. So in this class, I have defined a mouse event which extends the JFrame and implements the mouse listener. So JFrame, so we are defining a label named as L1, J label. So this JFrame, J label and all are components of the swing class, and they came up from the they are much better implementation of the AWT classes. So they almost work the same as the the label or the frame classes of the AWT. So here we are making use of JFrame and this JFrame which implements the mouse listener interface, and in this we are making use of a label and we are naming that label as L1. So this label is used to mark the entry on all the mouse events. So whenever a mouse pointer enter this, so this whole square or this window is represented by the JFrame, and whenever the mouse pointer enters this window, this frame, we will display the message mouse entered. So in case it exits the window, if the mouse has exited the window, the label will be changed to mouse exited. So to display those messages, we make use of the label L1. So we are setting the background color as red, which is not shown here. This has to be put in comment line. So since it is not red, this window is making use of default color. This statement has to be comment line. And when we close this window, we are setting to close that window. So whenever we close this window, there may be several operations. It may either exit on close or it may hide that window. So there are various operations which is defined for the windows. So when once our work is over, we will just close the window. So when we press the close button of this window, what action has to be taken is defined by the set default close operation. So what it says is that it is telling that frame to exit on close. So the jframe dot exit on close indicates that when we press the cross button or the close button, this window has to be closed, and window will be closed, and it has to exit. Now we are setting the size of that frame to 400. So this size, size is of 400 by 400 columns by rows. Then we are setting the layout as flow layout. So that is why we have this mouse label which is placed coming to in the layout. So flow layout means it indicates it arranges the components in a line. So we just have one component here, so that is why it is so single. This mouse entered label itself is taken as a single component, and we are centralizing that component is aligned at the in the central alignment format. That is why it comes at the middle of the window. Then we have this font. This label's font is set to Verdana, and size it is of bold type, and size is of 20. Then we are calling the set font method on L1. That means L1 is our label. On this L1 we are calling the set font to set to the given F. So F we have defined as Verdana, bold, and size of 20. So this features will be set to the font on which this label will be displayed. Then its foreground color is set to blue, and its alignment is set to center. So that is why this label is coming at the center when the mouse enter or exit. Now once all these features are set to that label, we are adding that label onto the frame. So we call the add method to add that label onto the frame. Then we have to add the mouse listener to that label. So whenever that mouse enters or exits that window or the frame, some work has to be done, and that is defined by the mouse listener. So when this mouse listener event occurs, one of these will be invoked. So based on the entry and exit, one of these will be invoked. So let's say when the mouse entered the frame, it will invoke the mouse. When the mouse entered the frame, it will invoke the mouse entered event. So when the mouse is entering that event, what is this mouse entered event, mouse entered method doing? It is setting the label of L1 to mouse entered. So the text value of this label, the text value of label L1 is set to mouse entered. So when the mouse enter this window or enter this JFrame, we get the message mouse entered. So this is the output obtained when the mouse enters the frame. Now when you let's say when the mouse is moved out of the window, we invoke the mouse exited. So when the mouse is moved out of the window or the frame, the mouse exited event is invoked, and in that case the label's text is set to mouse exited. So we get this output. Similarly, when the mouse is released or mouse is pressed, we get all these outputs. So when I have not added the mouse released event output. So when the mouse is pressed, if the mouse is pressed, when we click the right or left button of the mouse, this event will be invoked. Mouse pressed or mouse pressed event will be invoked, and then for that case, it is setting the text. It is setting the label's text to mouse pressed. Similarly, if it is setting the when we click the mouse, then it will set the text to mouse clicked. And when we release the mouse, it will display the mouse released method. So all these messages will be displayed by the label which is L1. The label L1 will display all these messages, and we had set some font for that label, its color, their color, and given some alignment for that particular label. So these are the various. So we have like this. These are the 5 methods which is used by the mouse listener interfaces, which defines the mouse exit, mouse entered, mouse released, mouse pressed, and mouse clicked. So these are the 5 methods which is defined inside the mouse listener interface. Now similarly, we have some methods which is defined for key listener also. So key listener interface will be, key listener methods will be invoked when any keys of the keyboard will be pressed or released. So there are basically 3 methods: the key pressed, key typed, and key released. The key pressed will be invoked when any key is pressed, but key typed method will be invoked when the user types a character. So if you press the shift key or control key, it will not invoke the method key typed. It will invoke only the method key pressed and key released. So in our example, we have the main method inside this class, key listener Java example class, and we are setting the frame bounds to 100 to start at 100 and to at pixel point 100 and 200, and its length and breadth will be 350 to 350 by 300. And here also we are defining the default close operation to exit on close. So when the Windows close button is pressed, it will close that window, and we are setting the visibility to true so that frame will be visible to us. If we set it to false, then that frame will not be visible. Next, we have this key listener example, which is extending the JFrame and which implements the key listener interface. So here we have we are having 2 parts. We are making use of 2 panels. This is first panel, the light pink color, and the second panel is red in color. So inside the first panel, we have a text field. Inside the first panel, we have the text field wherein whatever keys are being pressed will be typed there. And inside the second panel, we have a text area which will display the keys, the ASCII code or the character which is being pressed and released. So in this case, for that, we have to define the text area as well as the text field. So we are defining the text field as data name. Again, these J text field and J text area are part of swings. So here we are making use of the text field named as data, and the text area is named as txt data. Then we are making use of a string S to display the messages. Now we are implementing the key listener example constructor, wherein we are defining 2 panels, the panel 1 and panel 2, which is of flow layout. Now the panel 1's background color is set to pink. So this part, that pink color one is our panel 1 and the red color one is our panel 2. Now we are defining the data text field as we are making it have a text field which contains 20 columns. So this is making use of the constructor of this form, J text field int columns, where it specifies where the parameter passed specifies the number of columns. So here we have 20 columns. And we have the text area to have 20 rows and 30 columns. So here we can have 20 rows and 30 columns. Then what happens here is that whenever we press a key, that will be entered into this text area referred by data, and whenever a data is entered in that text area, we have to display some message. So some event is occurring for that text area. So for that, we are adding the key listener to that data. So whenever a key is pressed, some event has to occur. So we are adding the add key listener for the data. The data means the text field. To the text field, we are adding some key listener event. Now these two text areas, the text area and the text field has to be added onto the panel. So we call panel 1. So onto the panel, so we are having this text field to be added into the panel 1, and the text area part, this white square has to be is the text area, and that has to be added onto the panel 2. So we call panel 2 dot add text data. And then these two panels are to be added onto the JFrame. So we call the add method on that panel. So add this panel 1 with border layout in the north part, and add the panel 2 with center layout in the center layout. So that is why we have one panel here and the second panel coming on the center location. Now, whenever we press a key, so in this example, I have pressed 4 keys. The first key pressed was shift key, and the second key pressed was the control key. So for those keys, only the key pressed and the key released methods will be invoked. But when we press any character, so when it will invoke the key typed also. So when I pressed A and F, it invoked the key pressed, key typed and released method. So here we are defining the key pressed method to take up any key event. So this method is returning the value, or it is setting the text to some data. So whenever a key is pressed, let's say whenever an ASCII, when the key A is pressed, it will take up return the ASCII code and its corresponding character. So here, when key A is pressed in the keyboard, for the key pressed, it will invoke these two methods, right? So it will invoke this method, which will in turn do these two operations. So what happens here is that this S is a string. So we store some data into that string, and that data is displayed onto the text on the text area. So here that string is the string stores the key code or the ASCII code of that particular key pressed, and it also stores to that string again the character, whichever character was pressed, that also will be returned. So when we press the key A in the keyboard, the first message will be key pressed 65. That means 65 is the key code of the character A, and that value is set to this string. And then the second one is key press. So this whole thing, the key pressed equal to, here we will get 65. So this whole thing, key pressed equal to 65 is added onto string S. And again, to that we are again adding the key pressed, which will return the key character. So this function, the get key character, will return the value A. So that is why we get this A here. And so when A is pressed, we get these two. We get the ASCII and the as we are we had written to get the ASCII code as well as the character for that particular event. So now that string contains these two messages when the key was pressed. Now this message has to be stored or has to be displayed over the text area. So we are onto this text of this. We are setting the text value of the text area to this string. So the string will contain, this S will contain these two messages. These two messages are contained into the string. So that will be added onto the text area. Now when the key A is pressed, it will invoke key pressed as well as key typed. So when it invokes key typed, the string, here also we are modifying the string. We are using a new string there, and that string will contain this message. So here also we have this get character. So it will display the value key typed. So key typed, it is taking the get key value character only. So that the value A will be stored into the string, and then this message is this message is written onto the text area. So we are setting this text part of that text area as the string. So that is why we get the key typed equal to A message in the key typed message equal to A in the output. Now this key typed will be invoked only when the characters are pressed. For other keys like Control or Shift key, no event or this key typed method will not be invoked. So when once we press the key, we will release the key also. So when the key is released, again it generates an event. So for that particular event, this is the operation which we have defined. So we are again setting the string to key released, which is taking the key ASCII code. So get key code means it is taking the ASCII code of that particular key pressed, and that value is set as the string. So along with this message, so we get key released equal to 65, and that once this message is stored into S, and then we are displaying that data, this text data. That means that text areas text is set to this string. So this key released equal to A will be displayed on the text area. So in these, when we press only character keys, will the key typed method invoked. If we, for other cases, for all the other keys, it will invoke only the key pressed and key released key. So that is all for the video today. In this, in preparing these slides, I have used the Java Complete Reference written by Herbert Shield, the 9th edition of Java Complete Reference, and I have also used Samantha Sir's website, the Oracle website for Java tutorial, and the Java T-Point website for preparing these slides. So in today's video, we have discussed about mainly the event handling, the how event handling is done, and what is delegation event model, and what is the importance of event source and event listeners, and also we have discussed some example of mouse and key events. So that is all for today. Thank you for watching my video.
Like, share and subscribe. Hit the bell icon for more updates.